Understanding hyperbolas. There are two different forms of hyperbolas, just like there were two different forms of ellipses and parabolas. The standard form of a horizontal hyperbola is x minus h quantity squared over a squared minus y minus k quantity squared over b squared, and that is set equal to 1. And also in this one, our c squared is equal to something different. Our c squared equals a squared plus b squared. Our center point is still going to be hk. Our vertices are still going to be a spaces from the center. So in this case, since it's horizontal, my x is going to change by a factor of a, so it's going to be h plus or minus a, comma, k, and those are going to be my vertices. And my focus points are c units from the center. So what that one's going to look like would be my h plus or minus c, k. And finally, the different thing about hyperbolas is they have what's called asymptotes. Asymptotes are lines that the graph will approach but never actually reach. So the asymptote for a horizontal hyperbola would be y equals k plus or minus b over a times the quantity x minus h. So if you put in numbers for b, a, k, and h, then you'll basically just have a linear equation, and that's the whole point. The standard form equation for a vertical hyperbola is obviously a little bit different. My y is going to be matched up with my a. So my y minus k squared over a squared minus my x minus h quantity squared over b squared, and that is equal to 1. And my c squared is still going to equal a squared plus b squared. My center point still going to be hk. Make sure you don't get those mixed up. My vertices, because my a was matched up with my y, it's going to change my k term. So h comma k plus or minus a. And my focus point's still going to be my c. Still going to change the same thing as the a changes. So it's h plus and k plus or minus my c. And those are going to be my focus points. And finally, the asymptotes, again, going to be a little bit different from the horizontal. It's going to be y equals k plus or minus a over b quantity x minus h. So it's the same except we flip the a and the b around. In this first example, what we want to do is find the standard form equation for the hyperbola. We're given both focus points and both vertice points. So we look at these, and we can look at either one of the sets, but what do they have in common? If I look at the focus points, the 2 remains the same. If I look at the vertice points, the 2 also remains the same. So what that means is that my y is always going to be the same, which if you look back, that would be in my horizontal parabola. So I know it's horizontal. So that would be x minus h quantity squared over my a squared minus y minus k squared over my b squared equals 1. Alright, so now I just need to fill in those numbers. So I need to find my a and my b and my h and my k. Well, the h and the k is the slightly easier part. So I just need to find the halfway point between the focus points. Because halfway in between there will be my center. Or halfway in between my vertices will be my center. So my center is going to be the midway point. Midpoint. So I'm going to take -1 plus 5 and divide it by 2. And the other one, I'm going to take 2 plus 2 and divide it by 2. Okay, so in this one, it looks like negative 1 plus 5 is 4 over 2, and 4 over 2. So my center is 2, 2. So that is my HK. So if that's my HK, I can go ahead and fill that part in. And I can have x minus 2 squared over a squared minus y minus 2 squared over b squared equals 1. And the next part is we need to find our a and our b. Well, the a is easier to find than the b because we know a corresponds to vertices. So I need to find the distance from the center point to one of those vertices. So that would be h plus or minus my a comma k. That's my vertice point. So that would be this one right here. So h is 2 plus a, and my k is 2. So 2 plus a, well, I don't know what a is, but I know that that whole thing equals 4. So 4 equals 2 plus a, and a must then equal 2, because 4 minus 2 is going to be 2. So if a is 2, I can put that in right there. And finally, to find b, I need to find c first. Well, c is the same thing as that with the focus points. So the distance from my center point to one of these focus points. So from 2 to 5, that's a difference of 3. So c is equal to 3. If I know c and I know a, then I can find c squared equals a squared plus b squared. C squared is 3, so that would be 9. 3 squared is 9. A squared is 2 squared, which is 4, plus b squared. Subtract the 4, and I get 5 equals b squared. Take a square root. So b equals square root plus or minus the square root of 5. And now I can put that in. So my final standard form is x minus 2 quantity squared over 4 minus y minus 2 quantity squared over 5, because square root of 5 squared is just 5, equals 1. Final answer. In this last example, we want to identify the center, the vertices, the focus, and the asymptotes. So first we need to put it in standard form. So we might need to complete some squares here. So I'm going to group my x's. So that's 4x squared plus 8x, and group my y's, minus 3y squared, and get everything else on the other side, equals negative 16. Now I can complete my square, so I factor out a 4x squared plus 2x, and then minus 3y squared. That one square is already completed, so we don't have to do anything, equals negative 16. Now my completed square plus 2 over 2 quantity squared plus 4 times 2 over 2 quantity squared. So that's going to give me my completed square of 4x plus 1 quantity squared minus 3y squared equals negative 16 plus 4 times 1. And then my next step is to simplify here, which is just going to be a negative 12. So I'm going to divide by a negative 12. And I have 4 and goes into 12 3 times, so that would be a x plus 1 quantity squared over a negative 3. And then double negative here is going to change it to a positive, so plus 3 goes into 12 4 times, and the y squared is on top, and now we're set equal to 1. However, this is not my standard form because my positive 1 always comes first, so my standard form equation is actually going to be y squared over 4 minus x plus 1 quantity squared over 3 equals 1. So my A is with the 4 and my B is with the 3. So right now I can say that A equals the square root of 4, which is 2, and my B is equal to the square root of 3. So I know those two things right away. And I can also find my center right away. So my center is going to be my HK, which would be, my H is with the X, so negative 1, 0, because there's nothing with the Y. And then I go on to find my vertices. My vertices are matched up with the A. So my vertices and with the Y, which means my H is going to stay the same. And I'm going to take K plus and minus 2. So that's going to give me my H, which is negative 1, K, which is 0. 0 plus 2 is 2. And my other vertice is going to be negative 1. 0 minus 2 is negative 2. So those are my vertices. And next is the focus points. So my focus points match up with my C. Well, I don't know my C. I need to find that first. I know C squared equals A squared plus B squared. And I know A and B. So C squared equals A squared, which is 4, plus B squared, which is 3. So C equals the square root of 4 plus 3, which is 7. So if that's C, the same thing that changes on my vertices is going to change on my focus. So C is going to be negative 1, 0 plus square root of 7, so square root of 7, and negative 1, 0 minus square root of 7, which is negative square root of 7. And then finally, the asymptotes. The asymptotes are probably the most difficult, but if you remember the formula, you'll be fine. Y equals K plus or minus. In this case, it is a vertical because my Y is the first one, so it's A over B, X minus H. Put in what I know. Y equals 0 plus or minus. My A is 2. My B is the square root of 3. X plus 1. The last thing you need to do is just simplify that. So you need to split up the plus and minus and distribute. So that's going to be Y equals 2 over square root of 3 x plus 2 over square root of 3, or y equals negative 2 over square root of 3 x minus 2 over square root of 3. So those are your two possible asymptotes. There are two asymptotes on all hyperbolas. So those are all your answers. So that's it for your notes over understanding hyperbolas. Go through the practice problems, make sure you can do this and you can graph these, and then go ahead and take your quiz.